You know how most software works, right? One service makes a direct request to another, and then it waits for a response. It's a pretty simple back and forth conversation. But what if systems didn't have to talk to each other at all? Today, we're diving into event-driven architecture, which is a totally different way of thinking. It's a world where services don't ask for things. They just announce what they've done and let anyone who's interested listen in. Okay, let's break this down because this is the core idea. On the left, you've got your standard request response. That's like a phone call. Service A specifically calls service B and then just waits. They are tightly coupled. If B is down or busy, A is completely stuck. Now look at the right. With an event-driven model, service A just shouts an announcement out to a central place. It has no idea who's listening, and frankly, it doesn't care. That's what we call loose coupling, and it's the secret sauce that makes the whole system way more flexible. So, we're talking about this new kind of conversation. But if it's not a request, then what exactly is an event? What are we actually talking about here? At its heart, an event-driven architecture, or EDA, is all about reacting to these things called events. And an event isn't a question. It's a statement of fact. It's a notification that something important happened, like an order was placed or a user updated their profile. The service that makes it happen, the producer, just announces this fact and moves on with its life. It has no idea who, if anyone, is going to pick up that message. The flow is actually pretty simple, but it's incredibly powerful. So first, something happens. Let's say an order gets placed. Step 2, the order service, instead of calling the shipping service and the inventory service and the email service, does none of that. It just publishes one single event, order placed, to a central hub. And then step 3, any other service that actually cares about new orders, like shipping or inventory, is listening to that hub. They grab the event and do their own thing. The most important part? The original order service never even knew they existed. Okay, I know this can sound a little abstract, so to see just how powerful this gets, let's look at a real-world example. And if you've ever played an online video game, you have definitely felt the pain of the laggy headshot. Picture this. You're in a fast-paced game. You see an opponent, you line up the perfect shot, bam, you fire. Your computer sends a shot event to the game server. But, the internet isn't instant, and in that split second, your opponent also moved, and their move event got to the server just before yours did. So by the time your shot event arrives, the server's reality is that the opponent isn't there anymore. The server sees a miss, and you're sitting there yelling at your screen, "No way, I totally hit them." And this creates a real paradox, right? Who was correct? From your point of view on your screen, it was a perfect shot. But from the server's point of view, based on the order the events arrived, you absolutely missed. Which reality is the truth? This is where the magic of event-driven architecture comes in. The server isn't just reacting to events as they arrive, it's keeping a detailed log of them. And here's the trick. Every single event has a timestamp of when it actually happened. So the server can ignore the arrival order, look at the timestamps, and basically travel back in time. It reconstructs the game state at the exact millisecond you fired, sees your opponent was right where you shot, and boom, correctly registers the headshot. It's justice. Now, this time travel thing is just one of the amazing abilities an event log gives you. It's not just a boring record of what happened. It's the key to unlocking some serious superpowers for your system. And all of these superpowers come from that central log. For instance, high availability. Since services don't depend on each other, one can go down and the others just keep chugging along. Then there's powerful debugging. You can perfectly recreate any bug by just replaying the exact sequence of events that caused it. No more guesswork. You can even bring on a brand new service by just having it read the entire history of events to get caught up. And you can add guarantees to make sure a critical event like process payment happens at least once so you never lose money. I really love this quote because it gets to the philosophical heart of the matter. A normal database just tells you the current state of things, the what. An event log tells you the entire story of how you got there, the why. You're capturing the intent behind every single change, and that is an incredibly powerful thing to have. All right, so far, this sounds amazing. Time travel, superpowers. What's the catch? Well, this power definitely doesn't come for free. EDA is not a silver bullet, and it brings its own set of really tough challenges to the table. Yeah, there are some serious trade-offs. First, anything that touches the outside world is tricky. You can't just replay an event that sends an invoice or you'll charge your customer 5 times. You also have to be comfortable with something called eventual consistency. That means different parts of your system might be slightly out of sync for a moment. Think of it like when your friend updates her profile picture, and it takes a few seconds for it to update on your phone. It'll get there, eventually. And finally, you lose a lot of direct control, and making sure the right services see the right data can be a real security headache. Let's make that replay problem crystal clear. An event like update user address, it's totally safe. It just changes data inside your system. You can replay it 1,000 times, and the end result is exactly the same. But an event like send invoice email, that triggers an action in the real world. Replay that one, and you're sending multiple emails, and you're going to have some very confused, very angry customers. And this question right here is what can keep developers up at night. In a normal system, you can trace a request from A to B to C. With events, a service just fires something out into the void. You don't necessarily know who's listening or what they're going to do with that information or what other events they might fire off. Trying to understand the full chain of cause and effect across the whole system gets a whole lot harder. So, after weighing all the incredible powers against the very real dangers, it all boils down to a single core philosophy, a totally different way of thinking about communication. You should announce, not ask. This right here, this is the whole thing in a nutshell. The traditional model is built on asking. It's, hey, shipping service, I have an order for you. It's a direct conversation, and it creates a direct dependency. The event-driven model is built on announcing. It's, attention everyone, an order was just placed. The service just broadcasts a fact about itself and trusts that whoever needs to know is listening. And so that leaves us with one final thought. Take a look at the systems you build or the apps you use every single day. Are they built on a tangled web of direct questions, creating all these tight dependencies, or are they built on a chorus of announcements, creating a system that's more flexible and resilient, but also way more complex to reason about? The answer to that question reveals pretty much everything about a system's greatest strengths and its deepest hidden weaknesses.